Hello everyone, I'm Marvinus Bagus Wicaksono, and today I would like to present my homework entitled Homogeneous Transformation Metric for Rotation and Translation. So, understanding homogeneous transformation metric is crucial for unifying rotation and translation in robotics. It provides a powerful mathematical framework to represent both rotational and translational transformation in a single metric. In this presentation, I will explore the concept of homogeneous transformation metric and its application in robotics. A homogeneous transformation metric in a 4x4 metric that combines rotation and translation in three-dimensional spaces. It allows us to represent both rotational and translational transformation in a single metric multiplication. By using homogeneous transformation matrices, we can easily perform complex transformations and manipulations in robotics. So this is the metric of translation in X, Y, and Z. And then this is for the rotational in X-axis. And then next is the rotational in Y-axis metric. And the last is rotational in Z-axis. Here, the application of homogeneous transformation matrices find extensive application in robotics. They are used to represent the pose of a robot in its workspace, enabling precise control of its position and orientation as well. Additionally, they facilitate kinematic modeling, forward and inverse kinematics calculations, and trajectory planning. So the use of homogeneous transformation matrices greatly simplifies the implementation of complex robotic systems. For example, we have a problem in rotational and translation of an effector position of our robotic arm. The robotic end effector will be rotated in z-axis 60 degree and translated in x-axis 8, and then rotate in y-axis 45 degree, and last it will be translated in y-axis 9. So first we have to determine the translational metric in three-dimensional space. This is the metric, and also for the rotational metric. This is in x-axis, y-axis, and z-axis. And then we can put those all value. So here for rotation in z-axis 60 degree, then the metric will be like this. And then for the translational in x-axis, this is the metric, and this is the metric of rotation in y-axis 45 degree, and the last is translation in y-axis 9. Basically, in the multiplication of the metric, we can multiply the first row of the first metric to the first column on the second metric. So after that, we can get the result. This is the first two metric on the left side, and then the other is the second metric on the right side. And this is the final result of our homogeneous transformation metric. Here, after we got the homogeneous transformation metric, we can calculate the new position of our robotic end effector after we rotate and translate in certain value. Here is the old position coordinate of our robotic and effector. And then this is the homogeneous transformation metric. And after we calculate, we multiply those matrices, we have the new position of our robotic and effector. In doing this all calculation, we can use a MATLAB software. Here the metric of rotation in z-axis, and then this is the translation metric in x-axis, and next is rotation in y-axis, and then the last is translation in y-axis. So after we determine those all matrices, we can start to multiply those all matrices. And here the equation of the rotational and translational metric. So after the calculation, we have this homogeneous transformation metric in our MATLAB. So in the conclusion, the homogeneous transformation metric integrates rotation and translation in robotics. This powerful mathematical tool represents and manipulates complex three-dimensional transformations. Utilizing homogeneous transformation matrices enables precise control and efficient planning in robotics application. So this is the end of my presentation. Thank you for your kind attention.